Okay, so number 6 is different now. Not set equal to 0. So again, you have the choice to plug in all the choices, see if any of them work. Well, obviously some of them are going to work. Which two will work? You could graph in the calculator and find the x-intercept. So for your work, I would expect to see a sketch of the graph and show me the x-intercepts. Or you could show factoring and setting each factor equal to 0. However, for this one, there's that extra step of setting it equal to 0. So if I subtract 16x on both sides, some of you are having difficulty with trying to combine unlike terms. X squared minus 16x are not like terms, so they stay separate. Then I would add 28 to both sides, which also doesn't have a like term, and I would put it at the end to keep it in standard form. The x term in the middle, the constant at the end. And you just set it up like that. You don't have to do any work other than just putting it in the right spot there. And now I have a trinomial where the leading coefficient is 1. They have to add to negative 16, multiply to 28. So I know I'm going to have x times x for the x squared, numbers that multiply to 28. 1 times 28, 2 times 14, 4 times 7. It's a positive 28, so they have to have the same sign. So they're either both factors going to be positive in the table or both negative. Since they're adding to a negative, I know they're going to be both negative. Which pair also adds to negative 16? The negative 2 and negative 14. Set each factor equal to 0, giving you the solutions 2 and 14. Okay, next one. First thing I see, it is set equal to 0, so I don't have to get it set equal to 0. They're all divisible by 3. Oh, no, they're not. No, they're not. Okay, so I have this leading coefficient, can't get rid of it, which means we are splitting the middle. Or you could graph it, or you could plug in. But I'm going to do splitting the middle. The number's going to get big here. 12, negative 72 is the multiply number. The add number is negative 34. So I'm going to bring down the 3x squared, bring down the minus 24 equals 0, and we have to find the two numbers that multiply to negative 72, add to negative 34. 72 has a lot of factors. 1 times 72, 2 times, I just mix up the numbers, 36, 3 times 24, 4, does 4 go into it? Yeah. 4 times 18, 5, no, 6 times, no, 8 times 9. 6 times 12. My bad. All right, and now they have to multiply to a negative number, which means they're going to have different signs. They have to add to a negative number, so the bigger number is going to be negative. And again, you could get all these numbers from the calculator by putting negative 72 divided by x. Which pair would also add to negative 34? It could have stopped after the first pair had I noticed. We have minus 36x, don't forget the x with the number, and plus 2x. So now I'm going to divide these first two terms by 3x and get 3x times x minus 12. Bring down the plus sign. These two numbers could be divided by 2, so I'm going to bring the 2 down, divide and get x minus 12 equals 0. So there we go with the x minus 12 twice, and then the 3x plus 2 equal to 0. Set each factor equal to 0. X minus 12 equals 0, so I know one of the solutions is going to be 12. Does that knock down? Oh, only one choice that has 12. So I know that I should expect the other solution to be negative 2/3 minus the 2 on both sides, get 3x equals negative 2. Divide by 3 on both sides, and I'd get negative 2/3 as expected. Okay, number 8, again, you could graph and show the x-intercepts, you could plug in to show what works, or you could notice that both of these terms could be divided by 2x, so we're going to use GCF to factor, get 2x times x minus 4 equals 0, then set each factor equal to 0, divide both by 2, you get x equal to 0, add 4 to both sides here, you get x equal to 4. So 0 and 4 are my solutions, and the final problem is a dots. This one seems to be a favorite. My two factors are x plus 3 and x minus 3. Set each factor equal to 0. And when you solve, you get -3 and +3. Okay, so you have 10 problems to complete to me by Monday afternoon. I hope that allows for you to have some nice family time for the holiday.